Guten Morgen, guten Tag und guten Abend in die ganze Welt. Mein Name ist Carmen und ich bin ein Lololept.
Salam alaikum, ni hao, guten tag, jambo, aloha, konnichiwa, ciao, annyeonghaseyo, aloha, sawadee. One of the fundamental things that you need to know about if you want to understand linguistics is the human vocal tract, which is the thing that pretty much allows us to talk about everything. When you think about the parts of your body that allow you to talk, what are the parts that you think about? Maybe you think of your lips and your tongue and your teeth, but is that it? I mean, it's a pretty good start, but of course there's way more to it than that. The entire vocal tract is actually pretty extensive, all the way from outside on your lips and up here in your nasal cavity down to your trachea and into your esophagus. The average length of the human vocal tract is about 17 centimeters for men and 14 centimeters for women, and that's roughly, for you Americans, like 5 to 7 inches. There are a lot of moving parts of the vocal tract that can change so many different aspects of the sounds that we make. So let's talk about all the different options we've got. Let's start from the bottom and make our way to the top, you know, like Drake would want us to. When you breathe, your diaphragm gets pulled down so that your lungs can enlarge to draw air in. And then when the diaphragm relaxes, the muscles around the ribs contract, which squeeze the lungs and push air up into your trachea. Obviously, when you're just breathing, there's no sound that happens in that movement, unless there's some sort of blockage, like if you got a lot of snot down there, if you're like me, you have asthma. Yeah, that's no fun. It makes a lot of sound. The air passes from the trachea through the vocal folds, or sometimes called the vocal cords, which is a lot easier to say. These are folds of tissue that are controlled by nerves in the surrounding cartilage and muscles. When you're just breathing and you're not making any sound, these folds actually open to allow air to move through without any obstruction. When you talk, though, these folds constrict, which allows air to move through them and vibrate. This is called phonation, or voicing. If you put your hand to your throat while you're making sound, you can feel those vibrations. They're vibrating at about 200 flaps per second. So voicing can make a big difference in certain sounds. Think about p and b. They are sounds that are made the same way, right? You purse your lips and you're pushing air through, but there's one exception. The b sound is voiced and the p is not. So go ahead, try it. Put your hand to your throat and say p, p. Initially, you don't feel that air, right? You don't feel that vibration until the at the end of it, p, 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 right? But when you go b, 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 you can feel it already. The vocal cords are housed inside of the larynx, which is also called the Adam's apple or sometimes the voice box. And if you move the larynx up and down while you vibrate those vocal cords, you're able to change the pitch of the sound you're making. If you move it up, the pitch becomes higher because you're actually shortening the length of the vocal tract. And if you move it down, you're lengthening the vocal tract, so the sound becomes lower. Think of it like a slide whistle. The vibration of the vocal cords can also affect pitch, and these are controlled also by some muscles that are within the larynx. Here's a cool thing about the larynx that you probably didn't know. It is attached to the hyoid bone, which is your only floating bone in the body. As you can see, there's already a lot of moving parts to the vocal tract, like we said already, but there's even some parts that can affect your speech that aren't part of your body. Food. What do you do when there's food in there? How does food not get stuck in our trachea and choke us to death every time that we try to swallow it down? How does that not happen? For that, you can thank the epiglottis. When you swallow, your larynx is actually moving up to allow room for the food to move through. And the epiglottis, which is a piece of cartilage that's at the base of the tongue and the top of the larynx, it actually closes over your trachea to sort of stop the food from coming in and to encourage it to move to the back pipe, the esophagus, instead. It's kind of like if you think about on a tractor, especially like those old cartoony tractors where you have the pipe and then it's got like the little hat on it. That's your epiglottis. It's in your throat right now. Sometimes though, of course, these two things don't work well. There's not a lot of good cooperation and you might get food stuck in your trachea. And that's what happens when you choke. You're not able to breathe because there's an obstruction in there. Coughing is your body's way of pushing air through the trachea to try to get out some sort of obstruction, whether it's food or snot or whatever it might be. And if that doesn't work, does anybody know the Heimlich? Once you go up past the esophagus, the trachea, the larynx, and the epiglottis, now you're in the pharynx, which is most commonly referred to as the throat. One interesting thing about the pharynx is that you actually can't do much to control it. It's at its biggest when you're doing nothing. All that the pharynx muscles can do is constrict. In fact, try this. Take a bunch of air in and pretend like you're swallowing it. You can feel that tightness that's kind of in the back of your throat back there. But of course, even though the pharynx can't physically do much, it's very important for the vocal tract. In non-human primates, for example, the placement of the larynx inside the pharynx is actually too high, which makes the pharynx too short. Some people even say primates don't even have a pharynx. That lack of space makes it very difficult for those primates to move their tongue as freely as humans can, which of course is super important for the production of speech sounds. We've kind of covered all of this part, so now we're going to go up the pharynx into the nasal cavity, kind of up here. This is kind of like a cave inside of your nose, right above your mouth and leading into the pharynx. The soft palate, which we'll talk about in a minute, can actually send air and vibrations up into the nasal cavity. The entire space is about 10 centimeters long, which is roughly 4 inches. You could think of it as kind of the length of your finger, which, you know, makes sense. It's about right. This goes from the nostrils to the throat, and it's separated by the septum, this little thing. You didn't know that had a name, did you? If you've ever had some major congestion, which now is the time for that, you're very familiar with your nasal cavity. It's wet and it's gross, but it's an important place for resonance in the vocal tract. Nasal sounds like and are only possible because of the nasal cavity. I'm trying to make the sound without my nose. The nasal cavity doesn't have a lot of muscle control, so you can't change its shape or structure in order to manipulate any sounds that resonate inside of it. Try humming, for example. You're still making sound even when your mouth is closed, right? Now keep humming, but pinch your nostrils right here. You can't hum anymore, right? It doesn't work. That's because by pinching your nostrils, you've now stopped the airflow from your nasal cavity. Now let's move on from the nose and talk about the mouth. The inside of your mouth is called the vocal cavity, and it's full of active and passive articulators. These are a variety of structures that we use to change the flow of air throughout the vocal tract and can therefore change the different qualities of sound. Let's start with the passive articulators. They're also called the resonator areas. If you feel your tongue along the roof of your mouth, you can feel a vast landscape that you've probably never even noticed before. So let me give you a tour of the roof of your mouth. First, right behind your teeth, you feel that little hill that drops off? That's called the upper alveolar ridge. Then after that drop off, there's this place where there's some weird lines, right? That's the lower alveolar ridge. There's some consonants that are called alveolar consonants like t, d, s, n, and l, where your tongue is actually touching the alveolar ridge in order to make those sounds, right? Next is this hard bony surface with a long line going through it. That's called your hard palate. And sounds that are made by touching your tongue to the palate are called palatal sounds. Then past that, way past the hard palate, there's this part that's kind of soft and gross feeling. That's your soft palate, or velum. If your tongue touches here when you make a sound, that's called a velar consonant. And then if you look way back in the back of your throat, you know that little dangly thing that hangs down in a lot of cartoons when someone's screaming or something, you see that? That's called the uvula. Believe it or not, there are actually some consonants that are caused by pressing the back of the tongue to the uvula, and these are called uvular consonants. These passive articulators are really important to know when you're discussing the different sounds that you can make throughout the vocal cavity. Now let's move on to the active articulators. First, the tongue is one of the main, if not the main muscle group that controls sounds in the vocal tract. The tongue has 52 muscles, and though it has no bones or cartilage, different parts of the tongue can move fairly independently, if you've ever known from kissing somebody. Some people even consider it to be the strongest muscle in the body. But if you think about it, it's also one of the hardest muscles to perceive. I mean, when your mouth is just at rest, it's kind of hard to tell where your tongue is in your mouth. Even when I asked earlier about where the tip of your tongue was touching and making some of those consonants, you probably had to think about it, right? There are actually different names for different parts of the tongue. Did you know that? Most people are familiar with the tip of the tongue. Just a few centimeters past the tip of the tongue, there's the blade. Then you have the body of the tongue, or sometimes called the dorsum, which is like the main mass of the tongue. And finally, far in the back is the root of the tongue, which goes back into the pharynx. You may not notice how critical these different articulators are on the tongue when you're making sound. Let's do a little experiment. Take a minute to say these words. Beat, bit, bet, bat, boat, bot. Beat, bit, bet, bat, boat, bot. Pay attention to where your tongue is as you're saying these. Beat, bit, bet, bat, boat, bot. Do you feel how your tongue, especially the dorsum, is starting to move back with each one? With the word beat, the body is close to the roof of the mouth, and you can actually feel the sides of the dorsum hitting against the back of your top teeth. But by the time you get to the word bot, your tongue is resting on the bottom of your mouth and there's a lot of space in the back of your mouth. Maybe it will help if you take away these consonants. So instead of saying with the B and the T, just make the sounds. E, I, a, o, ah. E, I, a, o, ah. Now you can see how just those tiny differences make a huge difference depending on what you're trying to say, right? If I say, I'd like to buy some beets, that is much different meaning than I'd like to buy some boats. Thank your dorsum. Now let's talk about the teeth. The teeth don't move. It's actually the jaw that moves your teeth, right? But they're very important for certain sounds. Think about how hard it is to understand your great-grandmother when she doesn't have her dentures in, right? It's nearly impossible. Consonants made with the teeth are called dental consonants. Besides the teeth, there's also the lips, which is another active articulator. These move around to control the way that the sound is pushed out of the mouth. Obviously, you can just leave your lips closed, not make any sound, or hum, like we did earlier. But even in the formation of speech sounds, the lips, of course, make a big difference. Think about the difference between the sounds E and oo. The only thing that changes is the way that you position your lips. Think about E, you smile, E, and then you have oo, ooh. Consonants made with the lips, like B and P that we talked about earlier, these are called labial consonants. Now here's a little quiz. Can you think of a labial dental consonant where you use your teeth and your lips at the same time to make a sound? That's right. And also V. Both of them, voiced and unvoiced, it's great. And that's pretty much it. Those are the parts of the vocal tract. Knowing the parts and the functions of the vocal tract is obviously really important in linguistics. But it's also really helpful for singers. And in fact, a lot of the information that I got for this episode came from websites for vocal performance. I would argue too that understanding the vocal tract is really important for anybody learning a second language. When I was learning Chinese, for example, it helped me a ton to understand that Chinese had a lot of post-alveolar sounds. Once I learned that, it was so much better. So I hope you have a whole new appreciation for the different parts of your vocal tract, all the way from your lips down to your trachea and your esophagus. We'll talk more later about phonetics and the International Phonetic Alphabet, which use symbols for the vocal tract. Soon we're going to have an episode about phonetics and the International Phonetic Alphabet, and understanding these things about the vocal tract are going to be invaluable when you talk about those things. In fact, here's a sneak peek. Take a look at this chart. This is the vowel map in the IPA. It shows where in the vocal cavity these sounds can be made, but if you notice, it's kind of in the shape of the vocal cavity itself, from the lips back to the uvula. That's because it's very hard to get an image of the human vocal tract, especially one that's in motion. But if you go to USC's, let me see if I get this right, USC's Speech Production and Articulation Knowledge Group website. They have a really cool series of video and MRI where you can see how sounds are articulated in the vocal tract. It's creepy and awesome. It's really cool. I could spend hours just playing on it. If you'd like to test your understanding on the vocal tract too, AustralianLinguistics.com also has great little exercises where you can try to label the parts of the vocal tract. Try it out. Let me know how you do. That can be what we do instead of a quiz for this week. So if you stuck around this far and you're still interested in the vocal tract, I think it's pretty safe to say that you are a Lugalette too. I'll see you next time. That lack of space makes it very difficult for primates to move their tongue freely as human can. Apparently I can't move my tongue either. And understanding this information about the vocal tract, I should start a food truck company and call it that.